this is a question on series. And the first part is we've got this progression where this is the first term, sine squared theta. And we've got a range for theta, a domain, sorry. And the second term is this one here. And for the first part of the question, we've got a geometric series and we've got to find the sum to infinity. All right, so first thing is I know that A is equal to sine squared theta. In other words, that's my first term. And given that the second term, which in a geometric series is going to be A times R, is sine squared theta cosine squared theta, I therefore know that R is equal to cosine squared theta. So just from reading the question, I know this. Some of you didn't get what R was, which this bit here, but logically, if you've got sine here for A, and then your next term is AR, which you should know from a geometric series, then it's been times by cosine squared theta. Okay, so that must be the value of R. Okay, now we are trying to find the sum to infinity. So in your formula sheet, you have the sum to infinity. That is this bit I'm highlighting here. So at this point, we're going to chuck in our values. What's A? So the sum to infinity is equal to A, which is sine squared theta, over 1 minus R here. So 1 minus, and I found R to be cosine squared theta. And since I know my trig formula, I know that this can be simplified as sine squared theta over what's 1 minus cosine squared theta. That's also sine squared theta, which means the sum to infinity is 1. And that is as simple as simply what it is. Some of you got to this point here and were like, oh, that can't be right. Yeah, but it is. Sine squared theta divided by sine squared theta is 1. And then you crossed it out. So you were there, almost. All right, let's move down to the second part of the question here. Now we've got an arithmetic sequence. Okay. So we've got to find the common difference in this case. Okay, so what do we know? Well, we know A, again, is sine squared theta. And we want to find D. Well, we can use this here. We know that UN or U2 is sine squared theta cosine squared theta, and that's equal to A, which is sine squared theta, plus n minus 1 into D. Now, of course, n is 2, because we're in our second term. And we can simplify that. So sine squared theta cosine squared theta is equal to sine squared theta plus 1d, or d. And therefore, the difference is sine squared theta cosine squared theta subtract sine squared theta. And we can simplify that into sine squared theta into, whoops, wrong way, into cosine squared theta minus 1 equals sine squared theta into 1 minus sine squared theta minus 1 equals negative sine 4 theta. So that should be our difference. Okay, I've used my rule that cosine squared theta is 1 minus sine squared theta. And the reason I did that is because that we want this progression, the common difference in terms of sine theta, so I needed to get rid of that cosine squared theta. All right, so there we go. Right, now that's going to help us, I think, for this last part of the question. Now we're going to find the sum of the first 16 terms when theta equals pi over 3. So we want sum of the first 16 terms. And so for that, what formula are we using? We're going to use this one here, the sum one. Okay, all right, so what have we got there? Well, we know it's going to be half. Well, there's two formulas there. I'm not going to use the first one, I'm going to use the second one. Half times 16, bracket, so I'm using this one over here because that's the data I've got, time, bracket 2 times a, so that's 2 sine squared theta, plus 16 minus 1, and then I'm going to times it by my difference, which is minus sine to the 4 theta. Okay, and then maybe I'll turn those ones into square brackets there. Alright, at this point we want to put in our values for theta. So 1 half times 16 is 8, so outside that big square bracket we've got this, and then we've got 2 times sine pi over 3, and this is squared. That's what sine squared theta means, right? So it's sine pi over 3 times sine pi over 3 plus 15, well actually it'll be minus 15, so because this 15 times minus sine theta, so minus 15, and this one will be sine pi over 3 all to the power of 4. So at this point you might want to pop this into your calculator. Now obviously you need to make sure that you are in radians because pi over 3 is a value given to you in radians. So what do we get when we do this? Let's see what sine pi over 3 is equal to. So we'll have, next line we're going to have 8 into 2 times, and we're going to have, I think, 3/4 minus 15 into, and that will be 9/16, I think. Okay, and then we chuck that into our calculator. What do we get? I'm getting negative 55.5, or negative 111 over 2, and that would be my answer for this one.